And the last part of the January 13 paper asks you to find what the maximum of this is. There's a number of ways of doing it. Some people just work it out, but shall we multiply this out? Let's just multiply this out. We get 500n over 4,000 minus n squared over 4,000. And what we could do is differentiate this. So that cancels out to be an eighth there, doesn't it? So this just differentiates to be 1/8 minus 2n over 4,000. And you want to find out what the maximum is. And of course, maximums happen when this differential is equal to 0. So adding that to both sides turns out to be n would then turn out to be, he says, checking his notes, 250. That's the value of n. You don't want that. You want the value of t. So put the 250 in there and do this now very similar to what we did in this part here. Divide by the 500, flip it upside down, gives us this is equal to 2. Take away that, divide by 9, and find the natural log of it. And the answer then turns out to be 8 ln 9, or that's about 17, I think, 17 point something, 17 point blah, blah, blah. That's sort of, I mean, what are we doing there? We're actually finding d2n by dt squared is what we did there. Some other people just said, well, when is this? We're actually really only looking at what's the highest point of n times by 500 take away n. And by symmetry, you should know that that's a quadratic. Crosses down here at 0, crosses there at 500. It goes whoop like that, and the highest point there would be at 250. So you could actually just do it by inspection and then do the throw it into the last equation.